In this video, we are going to continue to study about the inverse of functions. And we studied before inverse of functions. This is the second lesson also, as you see here. And we are going to study about exponential and logarithmic function. Exponential and logarithmic function, they are inverse of each other. So when I have exponential function, the inverse of this exponential function is going to be a logarithmic function. When I have logarithmic function, the inverse of it, exponential function, is going to be, as you see, it's also explained here. So when you want to get x alone, you should send y is equal to, when you say y is equal to 5 to the power of x, you should get x alone only the way send this 5 to the other side. And if it is the exponential base, it should be logarithmic base of the other side. So it's going to be like this: logarithm base 5, logarithm base 5y is going to be equal to x. When x is alone, the function that you find here, it's going to be logarithmic function. So f to the power of f inverse x is equal to, only the thing that you should do here, instead of y, you are going to write logarithm, you are going to write x, so the answer is going to be logarithm 5x. As you remember, you are going to replace the y by x. Okay, here we have y is equal to logarithm base 2x. I want to get x alone, so I need to send the two other sides. This is logarithmic base. When you send to the other side, it's going to be exponential base. So 2 to the power of y is going to be equal to x. When you x alone, the other thing, what you find here, it's going to be inverse function. So f inverse x, the other thing I said, on the other side, what we have, it's going to be inverse function. So 2 to the power of y cannot be, because the function depends to x. So it's going to be 2 to the power of x. y replaced to x. And this is the inverse function of the logarithmic function is going to be. Okay. Here we have the graphs of the logarithmic function and inverse function. As you see, logarithmic function and exponential function, they are symmetric to each other. Which means, with respect to y-axis, if they are symmetric to each other, they are the inverse of each other. If I find any function here, let's say if I draw something like this, and the symmetric of it is going to be here, these two functions, they are going to be symmetric to each other. And as you see, logarithmic function and exponential function, when you get any point also, I will explain the symmetry like that. The distances, if the distances are same here, okay, when you get perpendicular line and the distances are same, it means that they are symmetric. Or you will get the point here, so from this point you will draw one perpendicular line to the y is equal to x-axis. There are two distances here, which is pink one and the blue one, and the distance to pink one and the blue one, and as you see, they are equal, it's going to be, and if they are equal, it means that they are symmetric to each other, and if they are symmetric, they are inverse of each other, is going to be. Okay, now we are going to find, by using the operations, the inverse of the function. Now here, if you remember, fx is equal to 10x, 10 to the power of x minus 1 plus 10 to the power of x minus 1 plus 2. When you say the operation order, Bedmas rule, by the Bedmas rule, first the exponents are coming, then Bedmas rule. Here I'm writing. First the exponent are coming, then addition and subtraction. So exponent here, then addition and subtraction there is. But when you get the inverse, the operations or operations, it should be inverse also. So first you are going to, if you want to get x alone, first you should survive from the 2, then you should get, and you should survive from the 10 because the exponential base. So I'm going to do like this: y is equal to 10 to the power of x minus 1 plus 2. Then this plus 2 goes to the other side. Y minus 2 is equal to 10 to the power of x minus 1, then this comes as a logarithmic base because we have x minus 1 and this is one term here, so that 10 should go to other side, and this 10 is exponential base, so on the other side it's going to be logarithmic base. So logarithm base 10 y minus 2 is equal to x minus 1. It's going to be x minus 1. X still is not alone, this minus 1 should go to other side, and it will be equal to logarithm base 10 y minus 2 is equal, plus 1 is equal to x. When x is alone, on the other side the function is going to be inverse function. So here this is the inverse function, only I should replace y by x. So f inverse x is equal to logarithm base 10. Actually logarithm base 10 is not written. I am writing for I have written for 3 of the function, but at the end I am not going to write y minus 2 plus, y cannot be, I said y cannot be, we should replace by x, then plus 1 is going to be, and I can write like this, logarithm x minus 2 plus 1, because the base is 10. Okay, the second example for the logarithm. So we are going to find the inverse as exponential, and this is going to be, it is not written here, but this should be from minus 4 to infinity to real numbers. Okay, y is equal to, I'm writing the function, y is equal to minus 1 plus 3 times logarithm base 2 x plus 4. And our main aim here to get x alone. How to do that one? Firstly, we have logarithmic expression here, but we have addition also. Before the logarithm, we are going to do addition and subtraction. We are going to survive from the addition and subtraction. We should send to other side. Y plus 1 is equal to 3 times logarithm base 2 x plus 4. This 3 can come in front of the, this is 3 times, that's why on the other side it's going to be division. Y plus 1 over 3 is equal to logarithm base 2 x plus 4. Now I should get rid of 2. On the other side it's going to be exponential base, so it's going to be equal to 2 to the power of y plus 1 over 3 is equal to x plus 4. And this 4 goes to other side. 2 to the power of y plus 1 over 3 minus 4 is going to be equal to x, and when x alone, the function that you find, it is the inverse function. That's why f inverse x is going to be equal to 2 to the power of x plus 1 over 3 minus 4 it must be. Okay, here we have quadratic function x squared minus 4x plus 4. So we should find a new method for this one, because x squared minus 4x cannot be factorized directly. Or when there are two terms, x squared and x, and they are not same term, in same kind of term. That's why we should try to write x squared minus 4x plus 4 in terms of x. And x squared minus 4x plus 4 is equal to what? First we should find that one. And y is equal to x minus 2 squared. It's going to be instead of x squared and x, I have now only one term, that is x. I can get the inverse of this function now. But here, as you see, there are two graphs. Why we have these two graphs? Because x squared minus 4x plus 4 is parabola. For the parabola, from the definition, you know that one here. The parabola, here it's going to be like this. The other side of the parabola, it's here. It's going to be like this. And when you draw lines like this, it's intersecting at 2 points, which means for 2x value we have one y value, and and for the inverse of the function there should be only one y value. That's why we cut the parabola into two parts. How we made that one? The parabola is defined on the positive side. You have to take, as you see, 2 to infinity and 0 to infinity. On the positive side it's defined. It's not defined on the negative side. So it's going to be like this. Y is equal to x minus 2 square. When you get the square root of it, square root of y is equal to x minus 2, it must be, but we have plus minus sign here. When you get the square root of the square, you should get plus and minus sign. And which one I am going to use, plus 1 or minus 1? Now this interval defines us the sign. Here both of them, they are positive. That's the y. That's why we are going to use the positive one. So instead of this one, this is going to be square root of plus square root of y is equal to x minus 2, and this is square root of y plus 2 is equal to x. When x is alone, it's going to be inverse function. So this is equal to f inverse x. F inverse x is equal to square root of x plus 2 for this interval. I want to show for the other interval also. This is going to be another example for this page, another example for this page. Let's say our function is from not 2 to infinity, from minus infinity till 2, which means this one. And 2 can be included here, it's no problem. Then till 0 to infinity, it's going to be 0 to infinity. Now when you find the inverse, this is the f domain and range, they are going to replace. So f inverse, it's going to be 0 to infinity to 0 to infinity to minus infinity till 2 is going to be. So this shows us the negative part, because it goes to minus infinity. It's defined to negative side, and f inverse is going to be on the negative side. So when we are writing square root of y is equal to x minus 2 for the second part, this is the second part, plus and minus sign again we have here. I wrote this one directly here, plus and minus. Which one we are going to choose? We have to decide about that one. We are looking the range set for the, or domain set for the f function. It shows us the negative part, so we have to choose the negative one is equal to x minus 2. So root of y plus 2 is going to be equal to x, and f inverse x is going to be equal to root of minus root of x plus 2. And here this is the second part. This is the graph of the second part is going to be